The homework assignment was page 84, right? Page 84. I wanted numbers, what did I say, 83 to 86, 95 to 100, and 105 to 110. All of those. And it looks like you are asking me for what? 98, 98, 99, 116, 106, 115, 117, 107. I'll look at all these and I will pick from this list. Any more people have? Let me know. Let's start early, 98, 99. Intermediate value theorem, 98, 99. Got it. So let's look at 98. So the intermediate value theorem says that, right, we have three checks. One, we have to check for continuity. Continuity. Intermediate value theorem. IVT. Checking for continuity on the what do you call it? On the interval. Make sure that the graph is continuous. Make sure our y is between the sections, between f of a and f of b, right? A and b. And then we state there is blah blah blah, f of c equals whatever our number is that we're looking for, k or whatever value we're looking for, right? That's bad. K, call it k. So 98 says we are looking at the function. So probably my guess is this cube root was a little confusing. We weren't sure about whether this was maybe continuous or not. From -9 to -6. And I wanted you to find f of c equaling 6. So, right, we were looking at this function. We wanted to know, does this function satisfy the initial value theorem and find the c value at 6. We also, a number of you messaged me over the week about these questions. We did not cover how to find c. We didn't cover that last class, but I'm going to talk about it right now. Show you how to find the c. If you're given a value, how can you, first of all, prove that it exists, prove that the c value does exist, and then second, find that c value. How do you make sure you find that c value? So I'm going to go over this right now with us here. So first of all, we need to make sure this function is continuous, right? We're checking the intermediate value theorem. We want to make sure that this value gets to 6. What is our low? What is our high? But is it continuous? Is the cube root function continuous? If you don't know what this looks like, look over the parent functions. In the folder on Schoology, I gave you a whole bunch of equations of parent functions. It's to your benefit if you were to know the general shape of all these kinds of equations. A cube root function looks something like, oops, not like that. Sorry, hold on. Looks something like this. That's a cube root function. Looks something like that. Kind of goes along. These are not asymptotes. These are not asymptotes. They go forever. Forever up, forever down. So its domain and range is infinite in every direction. Right? It's domain and its range. This goes up forever. This goes down forever. It goes forever side to side. And there's no break. There's no oddity here. Yeah, I should draw a little bit more precisely. Actually, what it really does is it kind of goes like this. Kind of goes like that. So this is a cube root function. It is continuous everywhere. Cube root function has no breaks, has no asymptotes, has no situations that we're worried about. The +8 just means it moves up 8 spaces, +8. So really, our cube root function is going to look something like this. Up at 1, 2, 3, 4, 5, 6, 7, 8, it's going to cross. That +8 just moves the function up 8, That's a vertical shift. These kinds of things, make sure we know how to interpret these. So, question number 1, is it continuous? Continuous? Yes. We're sure about that. It's continuous everywhere. I don't even need to worry about it. Cube roots are continuous everywhere. Square roots are another story. Cube roots, though, are fine. Second question, is it in the range? In range. So I need to plug in. I need to plug in my x. This is my a, and this is my b. I need to plug in these x's and find out what the y's are. So I'm going to find f of -9. That's going to be the cube root of -9 plus 8. Cube root -9. Do I know that number? Cube root of a negative. Is that possible? Is it going to be imaginary? What is this going to be? Cube root of -9. This is the kind of question they will never ask you to find a cube root of something like this on your own. They may ask you to find the cube root of 8 on your own. Anyone know what the cube root of 8 is? Or maybe the cube root of 64? Do you all know your perfect cubes? How many of you know your perfect cubes? Cube root of 8 is 2, because 2 cubed, yes, 2 cubed is 8. What about cube root of 64? Anyone know the cube root of 64? Perfect cubes? I have a guess. Yep, 4. Very good, Maria. 4. Jose, good. 4 cubed is 64. And 27 is 3. 27 is 3 cubed. Those are probably the most common cubes you'll be asked. If you ever see these are common cubes. 9 is not a cube, we know. So we will never be asked to find a cube root of 9 by hand. You will always be allowed to use calculators for these kind of questions. So I would suggest you plug it in. Plug into a calculator, cube root of -9. It's like going to be, I don't know, -2 point, like maybe 2. I don't know, maybe 2.1, maybe 2.01. Did someone plug it in and get a number for me? Cube root of 9? -2.05? I don't even know. Something around -2. A little bit more than 2, right? Because it's a little bit more than 8, but less than 27. Whatever. Plug into a calculator. Get that negative. Why is it negative? Well, cube roots, you have to remember, square roots of negatives, where am I going to write this? Square roots of negatives are imaginary. Right? Square roots. Square roots automatically have a 2, because you can't square something and get a negative. But cube roots, if you put a negative, the answer is just negative. Just like even or odd exponents. Negatives stay negative. So cube root of 9 is -2.08. Thank you, Paradiso. Plus 8, that's going to be -6.08. Yeah? So that's okay. That's our answer, 6.08. Great. And then we have next, that's the low end. Then we plug in our cube root of -6. F of -6, cube root of -6 plus 8, -1.8 plus 8. That's going to be, what is that? It's going to be 6. Oh wait, what do I write negative here? Not negative. This is not right, is it? It's 5 point something. 5.92. And this is 6.2, something like that. Yeah? Sure you're adding correctly. So our low end is 5.92, high end is 6.2. It does appear that 6 is between them, so we're okay. Even if we like estimate the numbers, that's okay. So now the question is, I want to find out what is the C value where it's equal to 6. Right, so we checked that it's continuous. We checked that it's in the range. We can state now, we would state, yes, because f of x is continuous, and 6 is between f of -9 and f of -6. You can even write it like this. You don't need to write the decimal numbers. You can just state that these are the values. Then there is a C. You have to state the range between -9 and -6, where f of C equals 6. That is the statement we would write. Yeah, that's our statement. Yes, since f is continuous, and 6 is between f of -9 and f of -6, you can right here, you can put the values if you want, the estimated values, but I would not risk it. I would just put these. Plug in, show me what you're plugging in. Then you say, yes, because that 6 is between those values, then there is a C between these two values, where f of C is 6. That's our statement. And then you find it, right? So to find C, what you do, real simple, you want it to equal 6, so you make your function equal 6. 6 equals the cube root of x plus 8. Right? Jessica's asking if you have to explain them. Well, you have to verify, right? So this is, it said to verify. This is the verification. This is the kind of evidence that you need to give before you're allowed to do the solving. It does ask you to find C, but it asks you to verify. I guess these first two steps are really verifying, right? You verify that it's continuous and that this is true. If you didn't state this whole thing, that's okay. But this would be the formal way. You would have to write this before you'd be allowed to. On the AP test, they would want you to write this before you would be able to solve. You would have to state that it's true. You have to clarify, you have to state, yes, it is true, therefore I'm going to be allowed to find C, therefore I'm going to find it. So, if you didn't do that now, that's okay. If you verified, as long as you verified with these two sections, where you checked out that it was continuous and you showed that it was in the range, you have to do that before you solve. You want to check first, because once you do your check, if it's not true, you don't even need to worry about finding C. You can't find it. You have to check first before you can find it. So when you find C, plug in FC, plug in, right, this is your 6, equals this number, and then you're just solving for x. Minus 8, cancel those. Not cancel, but like cancel the 8s. This is -2 equals the cube root of x. And how do you cancel the cube root? Cancel the cube root by cubing, everybody. Opposite of what you do. So in this case, x would be equal to, well, we just did this, -8. And so C is equal to -8, our value that we're looking for, which is, yes, between -9 and -6. There it is. All right. That okay? Questions about this? Right, you do your checks, you verify that it's okay, that you're allowed to solve it. You verified, it's okay. Move on to find C. What was our next question? 99? 99. Same thing with 99. Verify and solve. So we got this is a complicated one. F of x is x minus x cubed over x minus 4. And my range is 1 to 3. And I want to find f of c where it equals 3. So first of all, continuous. Check. Verify it's continuous. This function looks like it has a discontinuity, right? Discontinuity at positive 4. Is that a problem for us? No, looks like it's okay. This positive 4 is going to cause a problem because it's on the denominator here, but it says between 1 to 3. So we are continuous on the range of 1 to 3. In the interval 1 to 3, we're continuous. So that's okay on the interval. There's a discontinuity at x equals 4, but that's outside the range. Outside our interval. So we're okay. We're okay. 2, let's check for the check the y. Y in range. So we plug in f of 1, plug in f of 3, find the bottom and the top. I get 1 minus 1 cubed over 1 minus 4. That's going to be 0. 0 on the top over negative 3 is 0. Plug in a 3, I get 3 minus 3 cubed over 3 minus 4. That's going to be 3 minus, what was 3 cubed? Who remembers? Perfect cubes. This one they will ask you to do on your own. 3 cubed, 27, thank you. Over negative 1, that's going to be negative, nope, that's going to be positive something. 24, positive 24. So it looks like, yes, 3 is between those two, we're okay. 3 minus 27, negative 24, negative 24 divided by negative 1, positive 24. Between 0 and 24, we have a 3. So we're good. So let's solve it. Solve for C. We're going to plug in 3 equals x minus x cubed over x minus 4. And maybe this is where people got stuck. I feel like this is maybe where things got a little hairy. Well, we are going to do some things. We're going to try some stuff out. When you're solving these algebraic equations, right, they expect you to know how to do all the tricks. So I'm going to show you again all these tricks. We have various things we can try. First thing I want to do is I don't want to have any variables on my denominator, so I'm going to multiply both sides by x minus 4. Multiply both sides by x minus 4. Basically move this to the top. So I'm going to distribute the 3. I'm going to have 3x minus 12 equals x minus x cubed. Okay? Rearrange a little bit. This looks like some kind of maybe quadratic-ish equation. I'm going to add the x cubed. I'm going to move everything over to the other side. X cubed minus the x here, minus the x, add the x cubed. So I'm going to have x cubed plus 2x minus 12 equals 0. Yeah? X cubed minus plus 2x minus 12 equals 0. No parity, so it's not negative because we had negative 24 on the top and we have a negative 1 on the bottom. Right? 3 minus 27 is negative 24 and 3 minus 4 is negative 1. Negative over negative gives us positive. But this is a problem. If it was to the power of 2, if it was squared, I could solve this. I'd factor it, I'd find the a, right, the numbers there. But it's a cube. It's a cube, and don't have a lot of good strategies for factoring cubes. One of the strategies we talked about way back in Algebra 2, I don't know how many of you were in my Algebra 2 class when we did this. Maybe that was before, is we did group factoring. We split a problem in half, we did the A side, the B side, but that only works with 4 pieces. This only has 3. So how do we solve this? Again, they will never ask you to do something you can't do by hand almost in the entire test. Very, very few questions will you be required to use the calculator. This might be one of them. If they were to ask you to solve this complicated cube equation, I doubt they will do something like this. But if they were to ask you, how would we approach this? What could we do? What you need to remember is, what does it mean to be a 0? What it means to be a 0 is, if we had a graph, these would be the zeros. That's what we're looking for. Well, if we had a graph, we could find it. So let's graph it. On Desmos, on your calculator, you can graph this equation and it will solve it for you. Not solve it for you exactly, but it will show you where the zeros are. So, you know what, I'm going to go over to Desmos. Let's see if I can find this. And let me share Desmos screen. All right. So we've got, when in doubt, just go ahead and graph 2x plus 12. Was it plus 12, everyone? Minus 12. Minus 12. X minus 12. So here's our graph of this equation. Jessica, you absolutely can. I guess I haven't explained the format of the test to you. Let me tell you about the AP test. There's 4 sections of the AP Calc test. Yeah, there's 4 sections. 2 of them you can use a calculator, 2 of them you can't. There's a free response and a multiple choice section. And each of those is 2 parts. There's a calculator free response and a no calculator free response. There is a calculator multiple choice and a no calculator multiple choice. So for a couple of questions in each category, you'll be allowed to use a calculator. Not all of it, right? Not all of it. And a passing grade is a 3. Yes, passing grade is a 3. And I'm going to show you some out of 5. 3 out of 5. Yeah, the 9 thing, I'm going to talk about that. The free response questions, each free response question is out of 9 points. Taken the entire test all together, they give you a score out of 5. So they average all your points, things like that. And to be honest, the average score on the free response questions out of 9 is about a 4. About a 3. Actually, it's more like a 3. The average score on the free response questions is like a 3 out of 9. On the AP test, if you get an average of 2 points on every free response, you'll probably get a 2 on the test. 3 points, you get a 3. 4 points, you get a 4. It's out of 9, remember? So they don't expect perfection. 5 points, 5, right? So that's free. Again, I'll show you some of the results from the free response later on. But here. Let's focus on this one here. This is our answer right there. That's our 0 when x is 2. Right? So you graph it, you find the x-intercept, that's your solution. So if you're stuck on something, right, if you have a possibility of graphing it, it's a very handy tool to use this graphing. So our x is 2. Let's go back to the open board. And so we have our solution, x is 2. And is 2 between, what are my ranges here? Between 1 to 3? Yeah, perfect. Somewhere between 1 to 3. Between 1 to 3. That's a 0. To 24, there's my answer of 3. Okay, everybody? So in some situations, you're going to have to graph. Or I should say, not have to. I shouldn't say have to. It's an option for you. It's one of the tools that you have, graphing to solve these. Oh, that's an interesting idea, Jessica. Yeah, that's an interesting idea. Are you talking about using the squeeze theorem? Is that what you're saying here? F of A is less than C is less than F of B. I'm not entirely sure what that would mean. Do you want to unmute yourself and sort of explain that? Yeah. Yes, okay, I see what you're saying. Yes, definitely C has to be between 1 to 3, right? But we didn't know for sure if it was going to be 2. It could have been 2.5, right? It could have been 2.1, right? It could have been 5/4. We didn't know exactly that it was going to be 2. Yes, 2, the answer has to be between. But look at the first question, right? First question, we had our range, what was it? -9 to -6. Our C value could have been anything between there. It happened that we found out it was -8. But it could have been -7. Could have been negative, I don't know, 8.5, right? We had no possible way of knowing for sure just looking at the range. It's not always exactly in the middle, right? It's just a list of possibilities. To solve the actual possibility, you have to go through and solve the equation, plug it in, like make your equation equal the answer, and then you kind of reverse engineer and figure out what x needs to be. Does that make sense? I mean, what you're saying is true. Yes, C does have to be between 1 to 3, and that's what we did. That's what we said here, right? That's what we said here. Yes, because it's continuous and 6 is between these two values, then C has to be between these numbers. Finding out exactly what C is, you have to plug in. Yeah. Another way of saying this is, yes, -9 less than C less than -6, or A less than C less than B. Another way of stating this is using these inequalities. Somewhere between, right? C is between A and B. That's what it says. So yes, you can think of it that way, but to find the value, you actually have to plug it in. All right, what is the other questions? What other questions did we have? We had 106, 107, 106, 107. Wait, 115, 117? Why are we doing 115, 117? Did I put those on there? Oh, I did, didn't I? 115, 117. 115. Oh, and 116. Didn't I do 116 too? All right, let's do those first ones, 106 and 107. 106, 107. So these next section, I just wanted you to say if it was true or false. Not 160, 106. 106. This next section, I just wanted you to let me know, is this true or false? Thinking about how these statements work and what these are talking about. 106 says, if f of x equals g of x for x not equal to c, and f of x does not equal g of x, oh, whoops, sorry, f of c does not equal g of c, f of c does not equal g of c, then, making a claim, either f or g is not continuous at x equals c. So that's what this is saying. If f of x equals f of g for all numbers that are not c. So let's break this down piece by piece. What does this first part mean? If f of x equals g of x for all the numbers where x is not equal to c. What does this mean? What does this mean about the graphs of f and g? F is equal to g. What does it mean if two graphs are equal? F and g are equal. What does that mean? What does that mean about their graphs? Anybody want to take a guess? Alright, so let's say here's the graph of f. Where would I put the graph of g of x? What would it look like? If the equations are equal, if the graphs are equal, what's it look like? What's equal mean? What does it mean if graphs are equal? So let's say here at x equals 1. At x equals 1, the graph of f is right here. Where's the graph of g going to be if they're equal? Where's the graph of g going to be? Yeah, Jessica, they're identical. It's exactly in the same place. They're equal graphs. G is going to be exactly the same. Pardon my drawing, but they're exactly the same. The same graph. Same graph. That's what equal means. Yeah. Identical graphs. That's what this is saying. If f and g are equal, they're the same. If they are the same everywhere except this one spot, they're the same function, same equation, same graph, everywhere except right here at C. So let's say this is C. F and G are equal everywhere except right here. And at that spot, it says, at that spot, f of C and f of G are not equal. So what does that mean? If they're equal everywhere, and this is not except for C, and at C they're not equal, it's saying that means f or G is not continuous at C. Do you think that's true, or do you think that's false? If the two functions are not equal right here, if they're not equal, that means either f or G is not continuous at C. Is that true, or is that false? It'd be true. Who is that? Jennifer? Can you explain why? Yes, exactly. That's the only way this is going to work. Exactly. Thank you, Jennifer. There has to be a hole. One of the two graphs has to have a hole, and like maybe the G equation has a spot right here. right? Maybe the g equation has a hole where it jumps and the f equation passes through. One of them, though, if they're not equal there and they're equal everywhere else, then something has to change at that spot. There has to be some kind of hole or something. So this would be true. The graphs would have, one of the two would have to be discontinuous. Right? And there's no equation you can use. I mean, there's probably some formal equation you can use, but there's no need for an equation here. It's just kind of like you got to think about it. What's happening? If the functions are the same, except for right here at this spot, the only way they would be not equal is if one of them was somewhere else. And if something is somewhere else, that means it is breaking away from where it should be, and that's a discontinuity. So yeah, one of them has to be discontinuous. One of them has to break away. All right, 106. 107, same thing. Let's try it. 107. The intermediate value theorem. The intermediate value theorem guarantees that f of a and f of b, guarantees that f of a and f of b, that if, I should say, if that, not if, guarantees that f of a and f of b differ in sign, meaning one is positive, one is negative, when a continuous function has at least one zero, on a to b. Nope, what did I say? Sine of 1. Sine. My lesticia is showing through sine. Differ in sign. When a continuous function has at least one zero on a to b. So let's, again, break this down. Let's figure out what is this talking about. The intermediate value theorem, we know what that is, right? Low to high. Guarantees that f of a and f of b, so my low and my high, are going to have one positive, one negative, differ in sign. If they differ, it guarantees that they will change sign if I know that there is a zero, if the continuous function has at least one zero on a to b. And we just talked about what zeros are, right, of the graph. So is it true that we are guaranteed to have a sign change of our function a to b, f of a and f of b? Are we guaranteed to change signs from negative to positive if we have at least one zero? Let's think about this. A zero means a place where it crosses the x-axis. This is what we have. We have a zero. Right? Here's all my positive f of x's. Here's all my negative f of x's. Am I guaranteed that my graph has to go from negative to positive? Am I guaranteed that this has to be true if I have a zero? Does it have to follow this path? That's what this is asking. So what do you think, everyone? True or false? Do I have to go from negative to positive? Somewhere I have to change from negative to positive, right? Is that true? Or is that false? What do you think, folks? Type your answers in the chat. Am I guaranteed to change sign from negative to positive if I have a zero? Maybe I go down like this. Maybe I go positive to negative. Am I guaranteed a sign change? No one's answering. No one has any opinions. Can anyone think of a different way? I don't know if you think it's false. Jennifer thinks it's false. Seems like it would be true, though, right? I mean, like, it seems like it would make sense. Wouldn't I have to cross from positive to negative? Or is there a different way I could get a 0? No one else wants to answer? Am I going to give it to Jennifer again? Emmanuel? Angel? No? Lizette? Haley? No one wants to offer an opinion? I don't have any ideas? Stephanie? All right, Jennifer, take it away. Tell us why it's false. Yes, it can. Very good. That's exactly right. This is false. It does not have to change sign. False. We can do what she said. We can go down and touch. We could also go the other way, or we could go from the bottom side, right? We could keep it on the same side and just touch the axis, and that would be a 0. So there's other ways to do it, right? What we call this is a counter example. Right? This is a counter example. You've learned about these maybe in geometry. Counter example. It's something that satisfies the condition of having a 0. It has a 0, but it doesn't do what we thought. Right? It's a different way of getting it. And I guarantee you there will be questions like this on the AP test that want you to think of, well, is this true? Can this happen? Is there some other way this can happen? Think of all the different possibilities. How can you get a 0? Do you have to cross, or can you touch, right? Can something be continuous or discontinuous in certain ways? These kinds of questions come up a lot. I wouldn't say a lot, but they come up. They come up. So yes, this is false. You can go like this. You can touch the axis and not cross, and that counts as a 0. All right, what else? We had 116 and 117, right? Those are the next ones? Is that all of them? 116, 117? What have I got? Oops. 106, 107, 15, 16, 17. 15, 17? I gave you those, didn't I? All right, I'm going to do one of those. 15, 16, I'm going to do 115. I like 115. This is a good question. Number 115. Anybody want to read it? Let me summarize. So, in this question, what happens is a person climbs up a hill at 8 a.m. At 8 a.m. on Saturday, a person begins running up the side of the hill to their campsite. They go from where they started up to their campsite. Let's call it, I don't know, at noon. Doesn't matter, but sometime later, at noon. So at the base camp, and this is their campsite at the top. So this is Saturday. On Sunday, that person starts at the top at 8 a.m. and goes back down, I don't know, sometime later. Starts at 8 a.m., goes back down. Let's call it noon again. From the top back down to their base. The question is, at some point on the way down, the person realizes that they are exactly in the same spot at the same time they were on Saturday. On Sunday, when they go down, there is one spot somewhere on the trip where they are meeting in the same location at the same time. And we want to prove that that's true. We want to show that, yes, somewhere on their trip down, they will be in exactly the same location at exactly the same time they were on Saturday. How is that possible? How can we prove that's true? It gives us some hints, right? We have some S and R be the position functions for the runs up and down. So we can call this S of t, but we can call this R of t. And we want to prove that somewhere at some t value, S of t is exactly equal to R of t. That's what we want to prove. At some t value, these two functions are going to be exactly equal. I don't know what time, and I don't know what height, but somewhere they are exactly matching. And it says to use the intermediate value theorem to do this. Use the intermediate value theorem to do this. Oh, it says 20 minutes and 10 minutes, right? Okay, fine. So this is 8:20. 8:20 to run up, and 8:10 to run down. That's fine. 8:10, sure. 8:10. Okay. At some point on the way down, you realize this person realizes they're passing exactly the same place at the exact same time that they did before. Here, let me show you a visual way, then I'll show you the mathematical way. First of all, do we think this is true? Do we think that they pass by somewhere exactly at the same place at the exact same time? No matter how they run, no matter how it works. I can show you this is true. And what I'm going to do is, let's make a little graph. Here's 8 o'clock, here's 8:10, here's 8:20. On the way up, right, here's the bottom, here's the top. On the way up, let's do this in blue, the person goes from here. Maybe they go fast, and they stop for a while, and they go up again, and they stop for a while, and they go back up, and here they are at 8:20. They've reached the top, and that's on Saturday. On Sunday, they start here, and they go down. Maybe they really quickly go down, and then they slow down a little bit. And they really quickly go down again, and they slow down, and then they get to the bottom right here. But no matter how they move, there will be some location where they meet. Guaranteed. Guaranteed. Guaranteed crossing. And that will have the same height at the same time. Guaranteed. No, there's no avoiding it. No matter how, right, they go up, they come down. But no matter how they go up, they can go up super fast. Maybe they went up like initially really quickly and then slowed down. Still going to cross right there. Now it crosses right there instead of down below here. Maybe they go up really slowly. Maybe they start really slowly and then they go up really fast. Still going to cross right down here. No matter what, these two lines are absolutely always going to meet. There is some point on the way up and on the way down where they will be in the exact same spot at the exact same time. So visually, we can identify that. Visually, we can see, right? Visually, we can see what's happening. But how do we show this mathematically? How do we sort of describe this, right? So it says to apply the intermediate value theorem. Let's see, how can we do this? So between 8 and 8:10, the meeting time is going to be between 8 and 8:10. Right, between 8 and 8:10. Somewhere we want them to be equal. And it says to subtract them. I guess what we can do is we can say somewhere they will be equal, if the subtraction will be equal to 0. Because they're going to be higher than they were before. So on the interval 8 to 8:10, let's call this h of t is equal to s minus r, s of t minus r of t. Take our two heights and subtract them. Right? Take our two heights and subtract them. On the low end, h of 8 o'clock, right? Our top equation, our r, this is our r, and this is our s, right? R minus s, or s minus r, we're going to be like negative whatever the top height is. Negative whatever the top height is. And at h of 10, we're going to be positive some height. We don't know what, because at some point at 8:10 we know that the r equation is 0 and the s equation is more than 0. Right? We've gone up some amount. We've gone up some amount, right? We're here. So we switch from negative to positive. So h changes sign at the bottom. So because h changes sign, there is a t. Oh, stop it. Stop it. There's a t where h of t equals 0. And that's how we would show this evidence. Something like that. H of t equals 0 where the lines meet, where the height is equal. Something like that. Somewhere these two heights, at a certain time, somewhere there's a t where the two heights are going to be equal, where the subtraction will be 0. Because we started out with a negative height, and we ended up with a positive height. Because we changed signs, because they flip somewhere, because one's positive, one's negative, there has to be a value where it's 0, where the two heights are the same where they cross. Kind of weird. Kind of weird. All right, we're almost out of time. Any other questions about, I know we had 116, 117. 116, all you needed to do for 116 was remember the formula for the volume of a sphere. Anybody remember that? 4/3 pi r cubed. Oh my god, Mr. Mitchell. I haven't done any of that since geometry, or like 4th grade, or whatever. Do I really need to remember the formulas for the volume of a cube? Yeah, you do. Well, they do give you some equations. I will tell you on the AP test, they do give you some equations. But this is our equation, and it's basically 116 is basically a regular intermediate value problem. Find the low and the high. You know it is continuous. All spheres with radii from 5 to 8. There's one with a volume of 1500. So what is that radius? You make it equal to 1500. That's your volume. 1500 equals 4/3 pi r cubed. Find r. And use the intermediate value theorem to show that you can, right? Find the low, find the high from 5 to 8. Show that it exists. All right? So get this homework assignment into me. This is a lot. Look at all this, everyone. Ran out of room. I should start going higher. All right, there's not a whole lot of time for me to do the little odds and ends. I guess we'll have to do that next week. But I do want to tell you what I would like you to do for this weekend. What we're going to do is to review all the topics we've covered for limits. I would like you to do all of the limit section in Edgenuity. The AP Calc, I have assigned you all the AP Calculus class. I think you've all done a little bit of that when I had you try things in the beginning of the semester. But the way I would like you to review is I would like you to run through all of the sections in Unit 1, the limit section of Edgenuity. It covers all the topics we've talked about. That's going to be your study guide. So all the sections of the Edgenuity Unit 1 about limits, run through all those sections, and that's going to be your assignment over the weekend. Okay? That is a good question. I have not. You know what? I mean, do your best. It doesn't let you retake anything, does it? Like the questions, the practice questions. I'm not exactly sure how Edgenuity works. Has anyone tried it in other classes and seen? Does it give you a chance to? I know there's like quizzes and things, but I don't think I put any of those in there. Just like there's just assignments. Anything? Okay, interesting. So then I'm not. Man, that's not really useful. I'm probably not too concerned about the scores then. Again, I don't think there's any quizzes. Haley, I didn't put any quizzes, so there's no quizzes to like lock you out. Just do like there's just assignments. I think it's just like practices. It's a little different than other Edgenuity stuff that we've done. So there's like videos and there's like practice questions. And I think that's it. I don't think I put any quizzes in there. I think I took all those out. It's just the videos and the practice questions. And that's what I want you to do. Watch those videos, review with those videos, and then practice with the questions. See what they've got. Yes, the things on Khan Academy, I assigned those. I've also assigned all the things on IXL. You know what, let me share my thing here. Hide you. Back here. Here we are, Khan Academy. So Khan Academy, what I've done, I've put all the things on Khan Academy. We have the last little bits of limits and intermediate value theorem. For these, you know, and then on IXL, I've assigned you all the limits of infinity and the continuity stuff. All these. The thing I like about Edgenuity is I like that there's the videos that you can watch. Oh. Sorry, hold on. Here. Is it showing you now? Nope. Why is this not working? There. Here we go. So on Edgenuity, let me see if I can show you. Yes. So I've taken away all the quizzes. So right, there's just example problems, right? This section there's example problems. This section there's just example problems. And this section example problems. So there's just a bunch of example questions and videos to watch. So there's no quizzes to hold you back, right? There is the unit test. Don't worry about that. That may be the unit test we take, or maybe not. I'll have to look at it. But I want you to do all the practice questions, these 1, 2, 3, 4 sections in the limits and continuity section. It's a little review. I took out all the dumb things I didn't like. In Khan Academy, we have all these questions here about limits and practice. And in IXL, I assigned you all these things about limits and rational functions and infinite limits, etc. I would like you to start by focusing on Edgenuity, because I like those videos and it's good review to see everything again. But for practice, I like IXL and Khan Academy better. I mean, I would like you to do everything. Of course, I'd like you to do I want you to do it all. But the thing I am going to give you points if you do the Khan Academy stuff. I am going to give you points if you do the IXL stuff. But the thing I want you to focus on is the Edgenuity. So if we were to rank them, right, I would rank them in this order. First, Edgenuity. Second, maybe IXL. And I'd put Khan third. Just for question's sake. So work through the Edgenuity stuff first. If you get through it all and you want to practice some more, start the IXL equations. Check this out. Or if you want to go, check out Khan. But I am only requiring, your assignment is only to do the Edgenuity stuff. Your assignment is just to do Edgenuity. Practice those questions. I want to see how this works. I'm not going to require IXL or Khan right now. Okay, everybody? Is that clear? All right, yes. That's it, everyone. Thank you. Say goodbye in the chat. If there's any questions, you can stick around. But otherwise, have a great weekend. I will see you all next time.